Welcome back to IM1, everybody. This would be 5.1.1, part 3. So last time we wrapped up pretty much a new family of functions. So look back at the tables you created in the previous problems. What pattern do they all have in common? Functions that have this pattern are pretty much called exponential functions. So again, one of the things that I really want you guys to notice that like all of these were growing in an exponential form, meaning they were growing by multiplication. Here we were multiplying by 4, by 4, by 4, and so forth, right? Linear functions grow by adding or subtracting, right? So these actually grow by multiplying. Again, case 2, here we were doubling the previous month and so forth, right? And then on case 3, we were tripling the previous month. And then finally, case 1, we were just doubling what was happening, right? So we're going to take a specific look. First, let's answer the first question, right? So pretty much all of these all grow by multiplication. Oops. All right, multiplication. And again, these are called exponential functions. All right, so an exponential functions is when, and make sure you guys remember this, is when the x is the exponent. All right, so when the x is the exponent, those are our exponential functions. So now we're going to pretty much use resource page. Not in this case, we're actually going to use the E tool. So we want to graph the data for case 2, and then we're going to write a complete description of the graph as in part D. So in case 2, pretty much we started off with 10 rabbits, and each time it was doubling up, right? So we're going to look at precisely, we're going to do this over in Desmos. So we have it right here. The link should be right there for you guys as well. So again, we started off with 10, right? And if you notice, the first point has been plotted already. And then that was after the first month, second month. Let's do about 6 months in total. Okay. So after the first month, they doubled up. So we had 20, and then we had 30, and then we had, not 30, sorry, actually we had 40, and then we had 80, right? We're doubling them up. And then 160, 320, and then 640, right? So that's as far as we can go right now because pretty much it just makes it all the way up to 5. If you guys want to zoom out, you can actually see the last point over here, right? So here it says answer these questions about the graph if you haven't done so already. What is the domain? So the domain of the graph, domain in range. So if you notice, this will keep growing indefinitely, right? Meaning it's not going to stop. So we can say that first of all, let's start off with the domain. Let's do this so I can have a clearer picture of it. All right. Cool. Okay. I'll take a picture of this one. All right. So right here, what we're looking at is, again, looking at the graph, right? So in this case, I can say, make it smaller so it fits. All right. So we can say the domain of the graph, it starts off at 0. So starts at 0. So we can say x is greater than or equal to 0, right? Because we started at month 0. So this would be pretty much our domain, right? And it never stops, right? We continue moving month after month after month. And then the range. So for this particular function, right? For this particular function, we started off at our lowest point was 10. So anything above 10 as well, right? Anything above 10 is our range. So is this continuous, meaning points are connected, or is it discrete, points are not connected? Here I want to say that it's discrete. So this is a discrete function because it represents the number of rabbits. If it was just a numerical function, then yeah, we could connect all the points, right? We can say it was a continuous function. But since the situation here, we're talking about the number of bunnies, and you can't have half a bunny. That's why it is discrete, right? Because we were talking about the number of bunnies. All right, so is it a function? So if I were to connect all these points, right? If I were to make it a continuous function, you guys would see it right there. So we can say, yeah, this is a function, right? Because even if it's a discrete function, it only touches one point whenever you guys are doing the vertical line test, right? Remember the vertical line test? You can just pass your pencil vertically. If it touches more than one point, it's not a function. Here, it only touches one point, so we can say yes, it is a function.